Okay, here we go for the last example. Promise this one's short. Filling in, I'm going to write this in a different way. X over 2 is unfamiliar, but we're used to seeing it maybe a fraction out front. And remember that if I write it as a half x, if I want to put this together into one piece, I just multiply the fractions x over 2. They're the same thing. So I'm going to write it as a half x, and that way I know what my b value is, right? My b value is a half. Domain, boring. It's always real numbers for sine and cos functions, even if they're transformed. Range. Well, the range, I haven't moved it up at all. No move up. Just I have an amplitude of 3. So that means it goes from 0 to 3 and negative 3. Amplitude is 3. Notice this is one of those examples where here we cut off the minus sign. We never think of an amplitude as being negative, but we do think of there's some sort of flip going on here. Now what's the period? Well, we see that the b value is actually a half. So how is this going to work? I need some time to some room to think here. I say the period is 2 pi divided by that b divided by that number that's in with the x. 2 pi divided by a half looks weird. Let's write it in a better form. Divided by 1 over 2, which is actually, how do I deal with fractions? Dividing fractions, I invert and multiply, and this makes total sense because I got trapped into thinking of it in terms of the phase shift in B, or sorry, the period in B's and all that stuff. If I would have thought of it as, the opposite transformation as I'm used to, remember, this represents a horizontal expansion, right? Multiplying by a half should squish it, you'd think, but it actually goes opposite in the direction of x, expanded by a factor of 2. So the period is 4 pi, and I can think of the important points over here as pi over 2 divided by a half, which is actually pi over 2 times 2 over 1 every pi. Where it was 3 ticks, divided by a half is actually 3 times 2. It expanded by a factor of 2 every 6 ticks. The phase shift, no phase shift, 0. No axis change, and so this one should be pretty quick, although there is a couple things we have to worry about. All right, set up my scale, my axes here. Bam, bam. We're getting good at this, aren't we? Practicing all the time. Pi over 2, pi, 3 pi over 2, 2 pi, and I'm going to go up to 3 and minus 3. I don't have to worry about a vertical displacement here. The x-axis is still the vertical displacement. And I'm going to think about now, where's my first important point? Well, I don't have a phase shift. I don't have an axis change. So the first important point is, whoops, going the wrong way, is exactly where I would have thought at the first spot for the sine curve, right? The first hasn't been moved, so it's right there. And now I think of the important points. Normally it's every 3 ticks, but we said with this period change, it's every 6 ticks. It's every pi. So instead of every 3 ticks, every 6 ticks, important point. Now instead of being up at 1, the amplitude makes it up at 3. Every 6 ticks, important point. Now I goofed. Did you see the goof there? The goof was I forgot about the reflection. What does this actually do? This actually flips it, makes it goes reflected. And I'll think of it as moving down first. So instead of going up to the maximum, it'll go down this way. And instead of going middle, high, middle, low, middle, high. It'll go middle, low, middle, high like that. It's still only going to get 3 points in from 0 to 2 pi because it's been horizontally stretched. And that's it. Done. There's the homework. Some optional stuff just for fun, and then an FAQ.